afternoon, depending where you are, everybody. So my name is Pablo Moyano. I am assistant professor at Washington University in St. Louis. So the course that I teach in collaboration with is the one that is on the screen. Is a precast concrete enclosures. It's really a hands-on project, as you will see. And the whole idea of this course is to focus on design envelopes, building envelopes, mostly from an architectural standpoint, not so much from an engineer standpoint. So some courses, as we've seen today, are more technical. It's really talking about reinforcing and pre-stress and so on. So even though we use concrete, of course, it's precast concrete, the focus of the class is mostly design of envelopes. So, and the whole idea is to take advantage of resiliency, durability, low maintenance, well, all the properties that we all know very well concrete has, right? So the course that I'm teaching is in collaboration with Gay Precast, and also, of course, funded by the PCI Foundation grant. And again, the primary goal is the design and construction of full-scale mock-ups. So it's not just small, but really full-scale, to get the students the chance to interact with, with the precast construction industry, but also learn about the material itself. So this is the third time I'm teaching. It's actually the fourth time, but the first time was during COVID, so we couldn't do anything. It was purely just drawing. So, but this is the third semester in which I'm able to, the students are able to actually design and fabricate the panels. And the students are all architecture students. We don't have at WashU now. We used to have, not now, civil engineer or structural engineer. So we only have architecture. So most students are typically a good mix of usually half and half, graduates and undergraduates. And let me go through. Okay, and so very quickly, without going to dive into too deep into the course, I want to give you an overview, but it basically consists of 5 stages. So we do a very quick research, which is mostly looking at precedents of precast concrete. Then we jump into design of the panel. I ask the students to have to design a building. So it can be generic or can be more specific depending on their interest. And then we jump rather quickly. We spend about 4 or 5 weeks on that. That's what we're doing right now. And then we jump into one panel, just narrow down to one panel, and then start the documentation for mold making. And then we spend almost half of the semester just doing that, building the panel, the mold. And then towards the end of the semester, what we do is we ship the panels to the Gate Precast facility, which is not that close. It's 5 hours from St. Louis. It's not that bad, but we cannot go many times. We do go at the end altogether, but well, we ship that there, and then we participate. The students participate of the casting concrete. We spend the night over there at near Nashville, in Ashland City, where the plant is, and the next day we can experience the demolding. Learning objectives, as you can see there, without going into too much detail, we try to, it's very, the class is very ambitious. I think we achieve most of it, but, there's different degrees depending on the student interest and each semester. But the whole idea is to understand precast, but also get the hands-on, right? So really focus on hands-on activities by making the molds and even casting the concrete. Of course, they need to represent things properly in order to get those shop tickets that they need to reinforce the structures, and of course the hands-on by making the mold themselves. We do interact with Gate also in usually Zoom meetings, sometimes personal meetings that they come over so they can oversee the students' design. So, and again, as I mentioned, the course is really hands-on. So it's the whole design build experience. They participated on that. So from very early stages of research, design, mold making, casting, and demolding. Now, in order to, in my experience, in order to have a successful outcome, it's very important to establish, the rules, not the rules, but the sequence of events that I have to go through to make sure that this is doable in time, and also they can actually get a panel that is buildable, right? So, of course, occasionally they fail, and it's fine, it's part of the learning process, but the idea is to have a little bit of certainty that what we cast is going to stay, the mold won't, break away, right? So that's why we have this conversation with Gate to make sure that what they propose, has a feasible outcome. So as you can see here, these are students are working on the mold making. As I mentioned before, this is one, in this case, Chris Galde from Gate. That was in a couple of years ago. He came over to the university to interact with students and really give feedback. So the design of the students has, as I mentioned, a feasible outcome. So this is also about experimentation. So I really try the students to push, Gate, usually that most of what they do, I mean, most precasters do very conventional, very stuff that is really conventional in general. So there's nothing wrong, but the idea is to really try to experiment, different geometries. Today with CNC, digital fabrication and all that, you can create very sophisticated molds without necessarily, spending a huge amount of time or labor, right? So of course, the whole idea is to learn from this. They're not experts at all, the students, neither me or students. And Gate is amazing because they are really open to experiment and really willing to support the students' ideas and of course give advice and experiment with us, right? So it's really a collaborative effort. So this is an example of the first time that there was in 2021, the spring. That was the first time we students were able to actually participate in the entire process. Even though we still were in COVID, we were able to cast that. So, and these are just the panels that the students made. As you can see, a lot of exploration in geometry, really a lot of focus on either water collection or sun filtration or directing views and experimenting different things. In this process, the students have to do this kind of drawings. So not only design and looking at how it would look like if this was a full building, but also, of course, focusing on the actual panel, making sure all the pieces are there with the precise dimensions to make sure they can come together and really be cast. So this is the same team, as you see. So each piece has like a puzzle-like. This is interesting because they use, we tend to take advantage of the things that most architectural precasters offer. In this case, you can put retarder on the concrete, as you can see on the image on the left, and then wash away the part that is not cured, and then expose the aggregates and create with the same cast very different colors and finishes on the surface. So again, that's for all students. Most of them have no idea about precast. They really learn about the material, the possibilities, and what is possible, right? Mostly from a design standpoint, but also from a performative standpoint. And again, this is we have at school. We have a typical wood shop, metal shop. We do have a CNC, some 3D printers, small also. Some students use small pieces in 3D print. So we try to incorporate a really mix of analog and digital fabrication as much as we can. We don't have robotic arms or any kind of super sophisticated, but we have a simple 3-axis CNC, but usually enough to get interesting geometries and morphologies. So, and this is, in order to take the panels today, what we do, we rent a truck, and then I am the one usually that drives the truck to Nashville, again, 5 hours from St. Louis, and then we give the form work to Gate. They actually do the reinforcing, and then the students, the following week, the students go all together to, in this case, to Ashland City, to the plant, to watch the casting. This is an example of that. We all were familiar with this, but so the students do 90% of the mold is done by students. So Gate, what they only do, the thing they do is to do the frame around, and then they put the reinforcing, and then they cast the concrete. Another example, again, usually a combination of digital with analog fabrication, and this is another example of the student work. So we talk about panel thickness, where the reinforcing should go, color, aggregates, also how you need an angle to the formwork, to the pieces to make sure they come out. So all that is part of the learning process. So the students really get into the precast nuances to make sure they can use, they can have a successful outcome, but also learn about what precast is about. They actively participate in the demolding, so that's very important because it's the only part that they can actually do themselves in the plant. The casting, of course, is done by Gate. We are really close watching and documenting that, but this is the real hands-on portion that can actually jump into the panel, start all together, demolding, being careful not to chip the concrete and so on. So very, very rewarding experience. So they exposed to, as I mentioned, the whole process, to all the design build, agenda. It's also interesting to notice that concrete is the only construction material that, as you guys know, is fluid, right? So only gets, well, when it cures, gets hard and very strong. So the idea of leaving their own mark is, for the students, it's like a symbolic, but at the same time, rewarding moment that they can leave, their own hands in the back of the panel. So it will also give a sense of identity. It's like ownership. This is what they did. That panel belongs to them, even though it stays there at gate, but they have something that, well, permanently the mark is there. And again, I think the people at Gate are really super, super good to work with, very, generous with the time, of course, with the resources, of course. But also, this is a win-win for everybody, because these panels that you saw are actually, stay there for a long period of time, so still there. And they told me that all architects from all over the country, when they do visit to the plant, they tour around these panels. So they are actually a good source of information for architects to see possibilities, right? So what can be done with precast that is necessarily, some of them may be more conventional, or not so much, but really shows possibilities that maybe you don't see elsewhere. So it's a good thing for them to show. So the whole process, of course, we have some moments of relaxation. So for example, when we have dinner, lunch together, while we're waiting the finals to be, to cure. Nashville is very close from Ashland City. It's only half an hour away. So we actually, I send the student, we go together, spend a night there, a little bit of fun, waiting for the next morning that we go very early for the demolding. And this is the stage of this today. I mean, this is already 2 classes, 2 different semesters together. The work is, as you see on the screen. And well, looking forward for this semester. We're working now. We're doing another set of panels right now, working on the design stages still. And well, and also we try to promote this and showcase what we do, not only the foundation, but also, for example, this is an example of like a facade institute that the facade tectonics that they focus on building envelopes. They showcase our work from last year. Okay, that's it on my end. Any questions? I'm happy to answer.
I was just going to note that WashU is hosting the ACSA annual meeting this spring.
Yeah, true.
So I don't know how many of you are going to that, but I'm going to be there.
Cool.
Any questions for Pablo?
How much longer, Pablo, do you have for your studio? Is it 1 more year? Or?
Yes, I have 1 more year. So this is my 3rd. It's actually my 4th, but because the first one we didn't spend any money because of the grant, because of the COVID, we push it 1 year. So I have 1 more spring, next spring.
Pablo, I was going to comment on, I mean, great work. I've been following your work before too. So I was just curious. I mean, given that you're driving all the way to Nashville or Asheville, and the Gate Precast you're working with, I was just curious. You think, we are testing some of this tornado shelter stuff, right, with the shooting. I was just curious if there is a way we could collaborate with you to make a panel, and then we can shoot it with our Canon. And then it could be a 6 feet 7 feet tall, and as long as it's lighter, so we can go with UHPC. I know Gate is doing UHPC, so there is something which we can do between the studios, and maybe that can make open eye for, make it like a little bit more challenging for our engineering students too. And then also I wanted to use this opportunity to get some of my upper administration to think about, hey, this is a good way to look at it, because right now when we show some of the small panels in our classrooms, yeah, they're like, oh, it's great, but then the non-engineering side of people don't see the the beauty of it, right? So I think so the bigger pieces with some kind of a impact, and that we could get some of our folks in other areas can get excited because
Yeah, absolutely. I'm very open to collaborate. I think I spoke with you before about
Right.
this. I'm very open. So for me, it's a win-win for everybody. So yeah, absolutely. Giving these kind of panels some more, some factual data showing, oh, this is actually on top of being, interesting from a design standpoint, it can also resist, category 5 tornado debris. So it's showcasing, the potential of precast, right? So absolutely, yeah, I'm very open. So yeah, for sure. And having engineers also collaborating with architecture students, I think it's an amazing experience. So you can actually take full advantage of the material, right? From a structural standpoint, but also a design standpoint. Yeah, absolutely.
okay, so maybe I will connect with you offline and see if we can hash out something with the gate guys to work with us.
Yeah, absolutely. It's great.
One of the things we have is that grant that if you want to travel to each other's university, we do have that grant to, to travel back and forth to university. So
That's great. Yeah, we can take advantage of that. Absolutely.
So-
Yeah.
The other thing is my department head is a structures guy now for next 2 years. So I think this is the time I can push it.
Okay. Nice.
all right.